All right, absolute value equations. The margin of error in the example at the top of the page is an example of absolute value. The distance between 66 and 69 on a number line is the same as the distance between 63 and 66 because it's 3 steps. From 66 to 69 is 3 steps, so that's a distance of 3. And from 63 to 66 is 3 steps, so that's a distance of 3. So if you could see on the number line, from 66 to 69 is 3 steps, and from 66 to 63 is 3 steps. There are 3 types of open sentences involving absolute value. That's when you have absolute value equals a number, absolute value is less than a number, and absolute value is greater than a number. In this lesson, we're only going to talk about equals a number. Later on, when we get to a later chapter, we're going to talk about absolute value inequalities and what to do with those. So look at the equation x equals 4. This means the distance between 0 and x is 4. So there's actually 2 answers to that problem. You could be 4 steps above 0, or you could be 4 steps below 0. What number do you land on? You land on 4 or negative 4. So if absolute value of x equals 4, there's 2 possible answers. X could be 4, or x could equal negative 4. So the solution set is bracket or brace negative 4, comma 4 brace. Now that's not a coordinate. That's not like negative 4, comma 4 on the, when you go to the left 4 and up 4. The braces indicate it's a solution set. So that means negative 4 and 4 are the solutions to this equation. Okay, so for each absolute value equation, we have to consider both cases. So to solve an absolute value equation, you want to first isolate the absolute value, so get the absolute value portion by itself, if it's not already by itself. Then you want to take both cases. So here's what you do. When solving equations that involve absolute values, there's 2 cases to consider. The expression inside the absolute value symbol is positive or 0. If it's 0, then it's 0. If it's positive, then the expression inside the absolute value could have been negative. So here's what this is going to look like. So if I want to solve this equation and then graph the solution set. So f plus 5, absolute value of f plus 5 equals 17. So that means that the f plus 5 inside the absolute value could be 17 for case 1, or case 2, it could have been negative 17, because if f plus 5 gives you negative 17, you take the absolute value of it and you still get 17. So that's the original equation. Case 1, you just solved the original equation, f plus 5 equals 17. Then case 2, you set it equal to negative 17 because, like I said a second ago, if the f plus 5 is equal to negative 17, the original equation, you have to take the absolute value of that answer, and you would get positive 17. So here we just subtract 5 from both sides and get f equals 12. Here, you subtract 5 from both sides, but you get negative 22. Remember, negative 17 minus 5, if you do keep change, is going to be negative 17 plus negative 5. Put the negative on it, which gives you negative 22. So there are 2 numbers that are solutions. You can put one at positive 12 and one at negative 22 on the number line, and those represent the solutions. Now, before we get into B, you can actually check this. If you plug 12 in for f, 12 plus 5 is 17, absolute value 17 is 17, so it works. If I put negative 22 in, negative 22 plus 5 is negative 17, absolute value of that is still 17. So boom, we're done, okay? Check, they both work. All right, how about b minus 1? Absolute value of b minus 1 is negative 3. Now, b minus 1, absolute value of b minus 1 equals negative 3 means that the distance between b and 1 is negative 3. Now, since distance can't be negative, the solution is the empty set. No solution, okay? So be careful. If you have an absolute value by itself and it's set equal to a negative number, the absolute value, the answer to an absolute value can never be negative. Now up here, why'd we do it set equal to negative 17? because we're trying to find the solution inside the absolute value that gives you negative 17, so that when you take the absolute value, you get 17. Here, we're saying that you plug in some number, subtract 1, take the absolute value of that, and then that's a negative number, okay? That can't happen. You can't take the absolute value of a number and get a negative answer, okay? You might get 0 if the number inside, and like if I put 1 in for B, you would get 1 minus 1 is 0, absolute value of 0 is 0. But you'd never get a negative number as the answer to an absolute value equation. Alrighty? Okay, so there's no solution for that one. All right, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So absolute value of y plus 2 equals 4. Since it's set equal to a positive, you do both cases. Y plus 2, the inside could be equal to 4 or negative 4. Subtract 2, and you get y equals 2. Subtract 2, and you get y equals negative 6. And those are my two solutions. You could write them with braces, negative 6 comma 2. And if you checked, if you plug in 2 plus 2 is 4, absolute value of 4 is 4, we're good. Negative 6 plus 2 is negative 4, absolute value of that is 4, and 4 equals 4, so we're good. Second one is the no solution, and you write the symbol for no solution as a 0 with a slash through it. The absolute value of something is set equal to a negative, can't happen, so there's no solution. You don't even have to try to do the two cases, okay? If you did, you'd get two answers, and then when you check them, they wouldn't work. Let me just show that to you, just in case you messed up, okay? So 3n minus 4 equals negative 1, 3n minus 4 equals 1. So I'd add 4 and get 3n equals 3, divide by 3, you get n equals 1. Okay, now if I put n equals 1 in here, I'd get 3 times 1 is 3, minus 4 is negative 1, but absolute value of that is positive 1. So that didn't work. Okay, so see, even if you did it and you checked, you still wouldn't get a good answer. So here, or you'd get an answer that didn't work. So 3n equals 5, divide by 3, n equals 5/3. So here again, put in 5/3. 3 times 5/3 is 5. 5 minus 4 is 1. Absolute value of 1 is still 1. But that's set equal to negative 1. So it doesn't work either. Okay? And those are like the only two possible things you could come up with. And the reason is because your absolute value is set equal to a negative number. Okay? Now I wanted to show you one more thing before I moved on. So if I have, let's say 4 minus 3 absolute value x equals 10. Okay? There's something I said at the beginning of the lesson where when you're solving absolute value equations, the first thing you want to do is isolate the absolute value. So for this equation, before you did case 1 and case 2, you would have to get the absolute value by itself. Okay, so I would subtract 4 from both sides, like this. You get negative 3 absolute value of x equals 6. Then divide both sides by negative 3. So you get absolute value of x equals negative 2. Now, unfortunately, in this case, you have absolute value equal to a negative number, so there's still no solution. All right? What I often see people do is they just change the sign. They take the absolute value off and set it equal to 10 or negative 10, like this. So they would do 4 minus 3x equals 10. Then they'd solve all that. Then do 4 minus 3x equals negative 10 and solve all that. And then go from there. All right. But remember, if you have stuff being done to the outside of the absolute value, like you're multiplying it, adding and subtracting from it or with it, you want to solve for isolate the absolute value first, then do your two cases if it's necessary. All right, so let me back up here. So ice cream should be stored at 5 degrees with an allowance for 5 degrees. Write and solve an equation to find the maximum and minimum temperatures at which ice cream should be stored. So for this problem, I'm just going to work you through this one. So the temperature of the ice cream, it helps if you draw this on a number line, should be stored at 5 degrees. So here's 5 degrees with an allowance for 5 degrees. Now what that means is that your target temperature should be 5 degrees Fahrenheit, but you can go up or down 5 degrees from that and it's still okay. So you can go up 5 degrees and it's still good, because it's hard to always get it right at 5 degrees. So you go up 5, which is 10 to here, and you go down 5, which is 10, or excuse me, 0 degrees. So what you want to do is, when you write the absolute value equation here, for this one, you want to do x minus 5 equals 5. Now, how'd I get that? Well, basically what you do is x represents the temperature that the ice cream is actually stored at. Okay? Then minus the 5 is from the 5 degrees that it should be stored at. So the difference, so here's how you're thinking of it. The difference between the actual temperature and the target temperature has to have an absolute value of 5 degrees. So this is how I kind of think of it. So when you're trying to write an absolute value equation for a situation, it basically comes out like this: x minus the middle number equals the range. In other words, how far up or down you can go. Okay, so the middle number, unfortunately in this problem, they were both 5s. So x minus the middle number is 5. And then from that, you can go up 5 or you can go down 5. Because the reason is because it's whatever it actually is, the difference between what it actually is and should be, the absolute value of that should be at most 5. Okay? All right, when given 2 points on a graph, you can write an absolute value equation for the graph. So write an equation for the involving absolute value for this graph. Now, if you think about what I just said, writing the equation, so if I can go from 11 to 19, I want to get the middle of that. Now, what's the middle of 11 and 19? Well, it's actually 15. The easiest way to find the middle of two numbers is to add them and divide by 2. So if I did 11 plus 19, divide that by 2, you would get 30 divided by 2, which is 15. Okay? So I want to find the point that is the same distance from 11 and 19. The easiest thing is to find the middle number, which you just add the two numbers, divide by 2. And that's a lot easier, especially if you have decimals or fractions in your problem. So that's the midpoint. And remember, my rule is that you want to do the absolute value of x minus the middle number equals the range that that number can, or the amount that that number can go up or down. So I can go up or down 4 units from 15. So the equation is going to be absolute value of x minus 15 equals 4. All right, so let's write an absolute value equation for this graph. Go ahead and pause the video. Okay, so we have 17 and 27. I'm going to add those up and divide by 2. So that's 44 divided by 2 is 22. Okay, so the middle number is 22, so it's going to be x minus 22 equals, now how far up and down can I go from 22? Well, if I go from 22 to 27, that's going to be 5 units. And if I go from 22 to 17, that's also 5 units. So it's equal to 5. All right. Sometimes people get all mixed up in their head when they're trying to write absolute value equations. But just think, find the middle number, and its absolute value of x minus the middle number equals how far up and down you can go from that. Okay. Now, if you just solve this equation, you can see how it works. If I do x minus 22 equals 5, that's case 1. Then you add 22 to both sides, and you get x equals 27. And if you do case 2, x minus 22 equals negative 5, and add 22 to both sides, you get x equals 17. Okay? And those two numbers correspond to the endpoints, the solutions on the graph that we started with. So it's kind of like they graphed the answer, you came up with the absolute value equation. You know, in the first couple examples we did in this video, we were given the absolute value and then we had to graph the solution. Okie dokie. All right, guys, that's it. Thanks for joining in. Mathematicians, you have a great day. Reach out to me if you have any questions. And as always, take care.